Excess limiting reactants. We are looking at page 6 of your homework packet, number 3. And in this problem, it looks like we're given the mass of sodium sulfate. I'm sorry, we're asked to find the mass of sodium sulfate, which I think is this. We're given grams of sodium hydroxide and grams of sulfuric acid. So which of these two things should we use a mole train to find out the sodium sulfate? It's the limiting reactant. So we have to first determine the limiting reactant here and then carry that through to figure out the mass of sodium sulfate. So first off, I'm going to balance my equation, which I think is already done. And then the next thing is this equation does not compare grams, it compares moles. So I am going to convert grams to moles. So 24 grams of sodium hydroxide were given. And now what I have to do is divide that by the molar mass of sodium hydroxide, which I pre-did over here. Na is 23, O is 16, H is 1. So I'm going to do this in shortened form and say that's going to be, let's try this, 24.0 over 40.0. So I'm taking what I'm actually given, divided by the molar mass, and I think that's going to give me, I'll just do that down here for NaOH, it looks like right at 0.600 moles. And that is moles of NaOH. So I think I'm going to put this right down here as well. I think I'm just going to put 0.600. Now notice this is a nice round number, but if sometimes you don't get a nice round number when you measure things, so then you'd carry 3 figures like everything else. Okay, so that is my moles of sodium hydroxide. And I'm going to do the same thing with sulfuric acid. That's H2SO4. It says I have 39.2, but the molar mass is 98.1. Because 2 H's is 2 times 1. Should say that equals 2. Made a mistake there. All right, so this should be a little 2 right here. And then 1 times 32 and 4 times 16, we get 98 or 98.1 grams. And what I am going to do is put that right here and say 39.2 divided by 98.1. And when I round it back, it ends up almost at 0.400, and that would be moles right here. And that's of the H2SO4. It's kind of lined up right here. So if I go down here, I'm going to call this 0.400 right here. Now my assumption is for products, you don't have any of these at the start. We have to fill this in, but I'm just going to put a 0 here and a 0 here. Before the reaction starts, you don't have any products yet. So we can always assume that these are going to be 0. Okay, so I balance the equation, I convert each thing to moles. Now I'm supposed to determine my limiting reactant. So I could look at this and say, by inspection, say, hey, 2 is twice as big as 1. What's twice as big as 0.4? My guess is 0.8, but I don't have 0.18. It looks like even though the NaOH is bigger, it's not twice as big. So I'm thinking NaOH is a limiting reactant. Another way to get this is just divide through this 0.6 divided by 2, and that's what I'm going to show right here. And maybe I'll draw it right here. I'm going to say the 0.600 over 2 equals, and I'll say it's 0.3. I'm not going to really worry about carrying the zeros. Just trying to get that there. Okay, now I take this 0.4, I divide it by its coefficient. So I'm going to take 0.400 over 1, and that equals 0.4. So what happens is 0.6 divided by 2 is 0.3, 0.4 divided by 1 is 0.4. The smaller these two numbers is going to be my limiting reactant. So I'm going to identify my limiting reactant right here as the NaOH, and I'm going to identify the excess reactant as H2SO4. Okay, so really to solve this problem, we could figure out the amount of excess and all these things, but we really can just take the limiting reactant and follow the mole train, or we could do an icebox with it, which I think I'm going to do. We know that all of our limiting reactant reacts. So if that last one is 0.600, then this is going to be 0.600 as well. Okay, without even worrying about this piece, I'm just going to go in here and say, hey, if I put 0.600 of NaOH, how much Na2SO4 do I have? And that's where I look. I say 0.600. I'm coming from 2 going to 1. So it's like multiplying by 1/2. So that's that transition. And it ends up being 0.300. And that would be moles right here. So if NaOH is 0.6, and that's my limiting reactant, I'm going to have half as many moles of Na2SO4 because this is a 1, this is a 2. And 0 plus 0.300 is still going to be maybe I'll just draw this in here. I'll say this is what? 0.300, and that's going to be moles of Na2SO4. So it doesn't ask for moles of Na2SO4, it asks for the mass of Na2SO4. So notice I'm looking for mass. So what do I have to do in this last step? I have to consider the molar mass of Na2SO4, which is 2 NAs is 46, sulfur is 32, 4 oxygens is 64. It's 142 grams per mole. And what I'll do is I'll take that 0.300 moles, maybe I'll just do it right over here. I'll take this 0.300 moles in its sodium sulfate, and then I'm going to times it by my 142 grams, and that would be per, well, let's draw this in 142 grams. If you wanted to write this in, you could say per 1 mole if you wanted to. So moles times molar mass, and that's going to give me, I believe, 0.3 times 142 equals, and I think you get 42.6 grams, and that's Na2 and SO4 right there. Okay, let's look at a couple of things that we did. We are given grams of 2 different reactants. So if I'm given amounts of 2 different reactants, I have to determine which one's the limiting reactant. The limiting reactant is going to help me determine the product. How do I do that? I convert grams to moles for each one, and then I can either do it by inspection or I can take the 0.6 divided by 2, the 0.4 divided by 1, and the smaller one's going to be the limiting reactant. And if we're trying to figure out amount of product, all the limiting reactant reacts. 0.6 here, 1-to-2 ratio, it's 0.3 right here. Now, what if I would have carried out a mole train with 0.6 and a mole train with 0.4? I would have gotten 2 different masses. If I do that, the smaller mass would be the one that is what you'd actually get. Okay, so you could end up doing a thing that way, and that would work out. But I usually just carry it through with the one I know is the limiting reactant. Okay, here is things you do not need to do for this problem, but I might just show you it in case you were interested in looking at that. And let's just get a different color ink. Okay, what happens here? This ends up being nothing left over. And I'm just going to go to my draw function. If I wanted to complete my box, 0.6 times 1 over 2, this would be 0.300. Again, really no need to do this for this question, but just showing the method on how it would be done if you were asked multiple things. And that's going to leave me with 0.100 excess. And notice 2 to 1 to 1 to 2 ends up being 0.6 to 0.3 to 0.3. And then this is going to be 0.600 if I were asked about water. So I could do 0.600 here. Again, that would be moles. And then this would be 0.600 here. You do not need to complete the box, so the stuff in blue wasn't relevant to what was asked, but sometimes you're asked multiple things, and that would be just how to complete it if you wanted to. All right, so that is an example of finding the amount of product given to the masses of two different reactants. Convert to moles, determine your limiting reactant, follow the mole train or use the ice box with the limiting reactant. Okay, you find out you have moles of Na2SO4 here, convert to grams through your molar mass. Hope that helps. Thanks for watching.